Have you tried trading by yourself and the results weren't, well, as you expected them to be? Have you wondered if maybe an AI trading bot can help? And if so, how you could create one? Well, that's exactly what we're going to explore in this series. Today, we're kicking off an exciting journey, building a cryptocurrency trading bot from scratch using the Alpaca Markets API, machine learning, Python and Jupyter Notebook, and we'll be using Google's Gemini as our AI assistant. Now, we want to use machine learning for our bot, because we know it's great for a lot of things. And as you might have seen in my previous tutorials or on my website, there are various machine learning algorithms we could potentially use, ranging from supervised and unsupervised learning to semi-supervised and reinforcement learning techniques. Choosing the absolute best approach right away can be a deep dive in itself. So, to get us started, for now, we'll keep it simple. We'll start by asking Gemini to help us create an AI trading bot using a general prompt, and see what it proposes. Alright, let's ask Gemini for help. I would like to create a trading bot. It should be using machine learning to trade BTC USD in 1-minute intervals and Alpaca markets. Can you help me with that? We could also note that Alpaca uses different symbols for executing orders and checking portfolio positions for Bitcoin, like we had to in the past. However, it seems like the latest AI models already know about this, so we might not need to go into as much detail. We can check what the model thinks about our prompt as it generates the answer, or we can skip ahead and just wait for the full response to appear. I like how Gemini started its response. It seems quite responsible, if I may say so, and it's something like I usually say as well. So, remember, before we write a single line of code, the super important disclaimer: this series is for educational purposes only. I am not a financial advisor. Trading cryptocurrencies, especially on short timeframes like 1 minute, is extremely risky and you can lose a lot of money. The bot we're building is a starting point. It's not guaranteed to be profitable. Always start with paper trading on Alpaca and stay there for a long time. Do not risk real money until you are absolutely confident and have thoroughly backtested and paper traded your strategy. This project is about learning Python, APIs, and machine learning concepts in the context of trading. Okay, with that out of the way, let's get started. After the initial warning about trading and using its model, we get an overview of some core components of the process and the program we'll be building. It's good to know what we'll be working on upfront. So kudos for that, Gemini. So, we'll be using Alpaca Markets here, specifically their paper trading account, which is perfect for testing and doesn't involve real money. We'll also need the keys to our account to interact with the API. To get them, simply sign up, log in, and navigate to your paper trading dashboard. Look for your API key ID and secret key. These are like your username and password for the API, so keep them secure. But don't worry, if you ever lose them, or expose them in a tutorial or elsewhere, you can always regenerate them. I've already got mine. I recommend storing them as environment variables for security, rather than hard-coding them directly into your script, but it's up to you. Alright, now Gemini wants us to set up our Python environment. I'm using a virtual environment to keep my project dependencies organized, so I'll be installing everything in that environment. And I also recommend you working like this. So we need to install the necessary Python libraries. Gemini suggests using Alpaca Trade API for interacting with Alpaca, so we'll install that. However, there's a newer library, Alpaca API, that Alpaca now recommends. We've used it in previous tutorials, and maybe we'll get to use it later here as well, we'll see. Gemini also wants us to install Pandas and NumPy for handling the data, scikit-learn and XGBoost for machine learning, and Pandas TA for technical analysis. And it looks like we already know which algorithm Gemini wants to use for this trading bot. XGBoost. Cool. So, after we install all of that, we'll be ready to go to the next step. And the next step is to set up the API credentials. Gemini recommends using environment variables for security. So, let's copy the code, paste it into our notebook, and see what we've got. As you can see, at first we import all the necessary libraries, and then we set up our keys. You can copy and paste your keys from where you've stored them, or directly from the Alpaca website if you've just created them. Once that's done, we can check what comes next in the program. Here, we use the keys to connect to Alpaca using the Trade API. If everything is set up correctly, we should see the message, connected to Alpaca paper trading. If we wanted, we could also check the account using the hashed out part of the code. But we won't be doing that right now. And it works. Great. So, Gemini did a good job. And we now have our Python environment set up for creating our trading bot. Now, it's time to move on to the next critical step, fetching the historical data our bot will learn from. As before, we copy and paste what Gemini prepared for us. But, as I'm looking at this code for fetching data, there's one very peculiar thing to pay attention to. See this here? Trade API, timeframe, minute. This phrase is actually in Bengali. If I say it right, a language spoken primarily in Bangladesh and parts of India, it correctly translates to timeframe and minute in English. But I wonder why it is in here. I've worked with a lot of AI-generated code, and I've never seen anything like this from Gemini or any other AI. They almost always stick to standard English keywords and library conventions. It's not a hallucination, because the translation is accurate, which makes it even more interesting. Have you ever encountered something like this in AI-generated code? Let me know in the comments. And the big question is, will this actually work in Python? What do you think? Well, you'll have to tune in for part 2 to see what happens.
Okay. So last time we started building our AI trading bot with help from Gemini. We asked Gemini to create a bot for us and we started copying and pasting the code into our Jupyter notebook. We managed to set up our API credentials and moved on to the data acquisition. This time we'll continue with that. If you've watched the previous part, you know that there is something peculiar about this function and that I even wonder if it's going to work, but we'll get to that in a moment, and meanwhile let's check what is in this function. This function takes in a symbol like BTC/USD, a time frame, like 1 minute bars, and a start date. The end date is optional, and if you don't provide it, it'll just default to today. Next up, we convert the start and end dates into actual datetime objects. That way, we can loop through them and fetch data chunk by chunk. Why chunk it? Because Alpaca limits how much data you can pull per request. For example, if you're using 1 minute bars, you can only fetch up to 10,000 rows at a time, which is around 7 days worth of data. So we have the loop that is designed to fetch 5 days of data at a time. Inside the loop, we make a request to Alpaca. If the response is empty, we print a warning and move on to the next chunk. We also sleep for a second between requests to be nice to the API and avoid rate limits. After all the chunks are fetched, we glue everything together. Then we clean it up by removing any duplicates, sorting the data chronologically, and making sure we don't go past the requested end date. Finally, we return the full data frame. And here is our peculiarity. Yeah, that's not a typo. Somehow, the word timeframe ended up in Bengali. It's probably just a localization or translation hiccup on Gemini's side. But maybe it's something different. Anyway, we finished our last part with the question, will this even work? And now we'll check it. So here we go. And as you probably expected, it didn't. Python took one look at dot and just noped out. I'm guessing Gemini was feeling a little too multilingual when creating it, or maybe it thought our code needed some cultural flair. Either way, Python doesn't speak Bengali yet, so we'll help it out by switching back to good old English. But before we do that, before we ask Gemini to fix the code, let's copy and paste all the other parts so we have everything in our notebook. And yeah, I know, if you're vibe coding in Cursor or Windsurf, you probably already have all the code sitting neatly on your machine. But here, we're doing it the old school way, just chatting with Gemini in the browser, so we've got to do a bit more hands-on copying. Anyway. Let's now copy the error message from our notebook into Gemini and ask for help. Hopefully, it'll know what to do, even if we wouldn't have. Fixing the code takes time, so let me just speed it up a little. And there we go, we've got our newly fixed code. Looks like Gemini does see the problem, so that's definitely a good sign. But will it work now? Fingers crossed. Let's copy and paste it one more time to our notebook. Let's add our Alpaca API keys we've used before. Restart the kernel. And here we go. And there we have it. The code works. We've successfully connected to the Alpaca paper trading account and fetched the data. Thank you, Gemini. You are the best. So, as you can see here in our data frame, we have timestamps, close, high, low, and open prices, volume, VWAP, and the Bitcoin symbol. That is cool. Now we can take another look at the code and see if anything's different from before. And here we have our time frame, minute. This time, in simple English. And we can even see that Gemini marked it as corrected. That's a nice touch. Okay, so now that we've got more working code, we can clean it up and structure it a bit more before moving forward. Let's go ahead and copy all the info Gemini gave us, along with our conversation, so we understand what was changed and why. I'm not sure yet if this is the best way to do it, but hey, it's how we're doing it for now. Honestly, I don't even know if there are any real standards yet for working with AI, what to include in comments, how to document the workflow, things like that. If you do, let me know. In the meantime, here thanks to this we'll have everything in one place. And once we have all of that, we can move on to the feature engineering step proposed by Gemini. For this, Gemini suggests using the Pandas TA library. It plans to use SMA, EMA, RSI, MACD, Bollinger Bands, and ATR as features. These are pretty common technical indicators, so that looks good. Let's see if it's actually going to work. And no. It doesn't. Too bad, I had high hopes. But that's okay. It just means we've got something to work on next time. In the meantime, you'll find all the code on my website. So if you want to play around with it and try making it work for yourself, go for it. Just remember, everything we're doing here is using a paper trading account and is strictly for educational purposes. The bot created by Gemini probably isn't the most optimized version, so this is not financial advice. The bot might not make any money, and could even lose some. So please be careful, and if you ever consider using something like this in a real trading environment, talk to a licensed financial advisor first. Alright. Okay. So we weren't able to create the features using the pandas TA library in our previous step. The likely reason for this is that the library is quite old and thus might be a bit outdated and might not be fully compatible with the latest version of NumPy. So let's ask Gemini to fix it by using a different library. Now, I've logged out of the previous session, so I don't have my last conversation in the history. That means I need to give Gemini some context about what was working and what wasn't. You might not need to do this if your workflow is different. Once I provide all the necessary information, I'll wait for Gemini to adjust the code, and hopefully, this new version will work properly. Fingers crossed. And there it is, our fresh new code. Let's then check what we have here. So at first, Gemini tells us that the problem we encountered is a classic sign of an older library not being compatible with NumPy, and it decided to replace the pandas TA library with the Finta library. Cool. You can read more of what it had to say on the matter if you'd like. Meanwhile, let's check out the Finta library on the PyPI repository. And there we have it. Now, it looks like it's even older than the pandas TA library, but hey, maybe that won't matter, and it'll still work. What do you think? Anyway, Gemini shares a few more thoughts about the Finta library and asks us to install it. So, let's go back to our notebook. Okay, before we install Finta, let's first run the code that was previously working for us. That means connecting to Alpaca and fetching the data. Cool. It still works. So, let's install the Finta library now. Wait for it. And there we have it. So now we can replace the feature engineering code that used pandas TA with code that uses Finta, and hope for the best. As you can see, we import Finta here as TA. We get some additional explanation about the code we already pasted in the previous cell, so there's no need to paste anything else here. And now let's see what we have in our create features Finta function. First, we make sure the required columns for some indicators are present. Then, we calculate features like the simple moving average, exponential moving average, relative strength index, moving average convergence divergence, Bollinger Bands, and ATR. And finally, we check if BTC data exists and contains data before running feature engineering with the Finta library. If everything is in place, we lowercase the column names, create a copy, generate features, and print a preview. Otherwise, we get helpful messages and avoid errors by creating an empty fallback data frame. So now, after one last check to make sure we have everything we need, we can run this cell and see if our features are actually calculated. And it works. We've got our SMA, BBL, BBM, BBU, BBB, BBP, ATR, and returns after 1, 3, 5, and 10 minutes added to the table. That's amazing. Gemini, you did good. I think I can hire you as my assistant, if you're looking for a job. Okay, anyway. Now we can paste the second version of the code provided by Gemini. This version includes everything, both the newly generated code and the parts that were already working, so we get the full solution in a single cell. The only thing we need to do now is paste in our API key and secret key so we can connect to Alpaca. Let me find them real quick. If you're not sure what they are or how to get them, you can check out my previous tutorials. And it's done. Now, let's clean it up a little. Then, we can run the code to see if this version works too. And it looks like it does. It's fetching the data. And there we go, we have our data frame with all the data and calculated features. We even get the column names in the featured data, which is nice. We didn't get that in the previous version, so I guess Gemini must have changed the previously working code we provided. That's okay this time, but it's always good to check for changes like this before running new code. Of course, if you're using tools like Cursor, Windsurf, or something similar, you might be able to see exactly which lines were changed. But here, since we're working with the online chatbot version of Gemini, we don't get those highlights. Okay, anyway, the code works. Great. Thank you, Gemini. So that's our full working code for now. And now we can move on to the next step, creating a machine learning model, defining target and training the model. So let me copy and paste what we had before from Gemini. And let's ask Gemini, giving it all the previous code, to adjust the code based on the changes we made in the feature engineering step. If you want, you can read through Gemini's thoughts on the matter and analyze the output step by step. But for now, we'll just wait for the full answer and use it without diving too deep into the details. Let's copy and paste the answer Gemini provided. And actually, let me tidy things up a bit so I know exactly where everything is. Keeping your notebook clean and well organized is always a good habit. It saves you a lot of headaches later on. If you're working with AI like I'm here, it's also helpful to include the prompts and the AI's answers as comments or markdown cells. Those can be really useful when you revisit the notebook, helping you remember why you made certain decisions or how you got your results. Plus, after taking a break, whether it's days, weeks, or even months, a clean and well-documented notebook makes it much easier to pick up where you left off without getting lost. So, don't underestimate the power of good notebook hygiene. And finally, let's copy the code for our adjusted step 4. Alright, so here's what this code does. First, it prepares our data for training by creating a target column, basically checking if the price goes up after a few minutes, and labeling that as 1 or 0 if it doesn't. Then, it cleans the data, drops unnecessary columns, and splits it into training and test sets without shuffling, which is really important for time series data like this. After that, we train an XGBoost classifier on the features we created earlier, and if everything goes well, we get accuracy, a classification report, and even the top 10 most important features. The code also includes a bunch of helpful checks to make sure the data isn't empty, the right columns are there, and that we don't run into any nasty surprises during training. Super useful when you're building something step by step like this. We'll talk more about it in the next part of this tutorial. In the meantime, let's also copy and paste Gemini's final notes about the key changes and considerations for this part of the code. And that's it for now. And now that we have the code, we can go ahead and run it. In the next part, we'll take a look at whether it actually worked. Of course, you can run it yourself. You'll find the notebook on my site. Okay. So last time we wrapped up with our features created, including SMA, EMA, RSI, MACD, Bollinger Bands, and ATR. We also pasted in the code for defining and training the model using XGBoost, which we got from Gemini. Now, let's take a closer look at what's inside that part of the code. First, let's check what Gemini tells us about the key changes it made to the code, and what considerations we should keep in mind. So basically, Gemini made the code more robust by adding checks for missing data, improving how features are selected, and simplifying the XGBoost setup for newer versions. It also clarified the target definition, added error handling and print statements for better feedback, and gave options for upgrading to a more advanced multi-class trading model later on. That's cool, thanks Gemini. Okay, so here we start by preparing the data, creating a target based on future price movement, selecting relevant features, and splitting it into training and test sets in time order. Then, we train an XGBoost classifier to predict price direction and evaluate its performance using accuracy, classification metrics, and feature importance. So let's see if it's going to work. And unfortunately not completely. So as usual, let's copy the outcome, paste it into Gemini, and follow its instructions on what to do next. So Gemini is telling us that the symbol column is causing issues because it's a string, and XGBoost only works with numeric data. To fix this, we just add symbol to the calls to exclude list in our prepare data for model function so it gets removed before training. The rest of the code should stay the same. So let's fix it and add all the info Gemini gave us about the problem and the solution. And now that we've fixed the code, let's run it and see if everything works. And it works. It's amazing how simple coding can be these days. Don't you agree? Alright, so as you can see, the model was trained using 17 technical indicators, and we can see 10 of the most important. Also, while the overall accuracy is around 51.5%, we can see it struggling a bit with class balance, especially on the positive class, but indicators like Bollinger Bands, SMAs, and MACD are showing up as the most important features. Cool. So let's save the notebook. Now, if we're unsure about what these results mean, we can always just copy and paste the output into Gemini and ask it to explain everything for us. And as you can see, Gemini gave us a pretty comprehensive answer regarding this output. It confirmed that the model trained successfully after fixing the symbol column issue and explained that we have over 4,400 training samples with 17 features, mostly technical indicators like SMA, MACD, and Bollinger Bands. The model's accuracy is about 51.5%, which is just a bit better than random guessing, common for a first try in noisy financial data, and it's better at predicting when prices won't go up than when they will. Gemini also highlighted the top features influencing predictions and gave practical next steps, like refining our target, improving features, tuning hyperparameters, and eventually backtesting to see how this performs in real trading. So overall, we have a solid working pipeline and a baseline model, and now let me paste it to our notebook, so you can read all of that if you want later. So, now that we've completed the machine learning part of the bot, let's move on to the next steps Gemini suggested earlier. This time, we'll try backtesting the model to see how well, or poorly, it would have performed on historical data. Gemini already gave us some code for backtesting, but we'll need to update it to fit the changes we made to the bot. Finally, we'll put everything together in our notebook and run the full workflow. So, as you can see, Gemini tells us to install Matplotlib and provides the code to run. Like before, it also explains the key changes and considerations, which you'll be able to read in the notebook. Basically, Gemini gave us an updated backtesting function that aligns model predictions with test data, applies realistic transaction costs on both buys and sells, logs each trade, and plots portfolio value over time for easy analysis. This simple, vectorized backtest assumes a fixed trade size and no slippage, providing a quick way to evaluate the model's potential before moving on to more advanced backtesting tools. So, let's install Matplotlib. And I already have it. Good. So let's continue with the rest of the code. So, as you can see, this function runs a simple backtest using the model's predicted signals to decide when to buy or sell. It assumes we trade a fixed amount each time and includes realistic fees on both buying and selling. The code keeps track of how much capital and BTC we have, logs every trade we make, and calculates the portfolio value step by step. Then, it plots the portfolio value over time, showing markers where actual buys and sells happened, which makes it easy to follow what's going on. Before running the backtest, it lines up the model's predictions with the test data prices to make sure everything matches up correctly. There's also some error checking to catch issues like missing data or feature mismatches. Overall, it's a quick and handy way to see how well our model signals would have worked in the past before diving into more complicated backtesting tools. So, do you think this code will run smoothly? Or do you expect any issues? We'll see the results in the next part of this tutorial, but if you want, you can of course download the code from my site and try it out yourself. Have fun. Okay, so in the last video, we wrapped up with the backtesting step. We got this code from Gemini, we ran it and were left wondering if it would work. Well, in this part of the tutorial, we're finally going to find out what happens next. Let's dive in and see how it all plays out. And here we go. It worked. Cool. So, we've got more than 1,000 rows of data and 25 features, with the predicted signals added in. We started with $10,000, but ended up with only $9,792, so not great. We lost 2%. And we made 214 trades, which you can see in the chart, here below, green buys and red sells. And it looks like Gemini added a section to our code that outputs the last 5 rows and trades, which is apparently pretty standard in backtesting to quickly identify any immediate patterns or potential issues. Good thinking, Gemini. And as you can see, the last 5 rows show the portfolio value holding at $9,792 with no trades. As for the last 5 trades, we saw quick buys and sells with small profits and fees, but nothing that really moved the needle. Okay. So now, if we want to learn more about all of that, we can simply copy it and paste it to Gemini and ask what it all means. And as you can see, Gemini provided us with a pretty comprehensive breakdown of the backtest results. After going through it, we can identify key factors like the high frequency of trades and transaction costs that contributed to the loss. This analysis helps us pinpoint areas for improvement, such as refining the signal quality and adjusting the trading strategy, so we have a clear path forward for tweaking and optimizing the bot. If you want, you can check out all the details in the code I posted on my site, but for now, let's leave it at knowing that the current strategy isn't profitable. Our model accuracy is around 51%, which isn't great, and we made a lot of trades, which resulted in significant fees. Oh, and by the way, I don't think I've mentioned this yet in this part of the tutorial, but just to be clear, this is only for educational purposes. It's not financial advice. We'll be running this bot on a paper trading account, so there's no risk to our real money. Yes, that's important. So now let's finally dive into live paper trading. The goal is for the bot to trade every minute, buying and selling Bitcoin, if you haven't caught that already. We've already gotten some code from Gemini that was supposed to do this, but now that we've made some changes to the earlier parts of the code, we need Gemini to help adjust the live paper trading section to fit with the rest of the code that's already working. Oh, and yes, I know I just said the model isn't great, but for our educational purposes, it's good enough. We'll improve it later, but for now, we just want to focus on getting a working prototype. So, Gemini, can you lend a hand? And there we have it, lots of code, explanations, and info on what to do before running it. We'll check everything in just a moment, but first, let's copy and paste all of it into our notebook so everything is in one place. I'm also going to clean up this notebook a bit now, so I don't get lost in it later. Or at least, so I don't get lost even more. Anyway, here comes the cleanup. And finally we get to the part with signal generation and order execution, live paper trading. So let's copy and paste all of that as well. As you can see, we have some key assumptions here regarding our API, our function for calculating technical indicators, our XGBoost model, and a list of feature column names. We set all of this up in the previous parts of the tutorial, so with that in place, the adjusted code should work. At least, according to Gemini. We'll see about that. And that's it. So now let's see what Gemini has to say about the changes it made, what's important before running the code, and how to integrate it into our project. And here's a breakdown of the key changes and enhancements. Okay, and here are these critical points Gemini made for us. So as you can see here, Gemini wants us to make sure, before running the bot, that we're using paper trading with the correct Alpaca keys. We also shouldn't forget to double-check that the model and feature calls are set up properly, and that the create features function is working. We should confirm the Alpaca API is connected, and also adjust constants like symbol 2 trade and confidence threshold to match our setup. And, of course, we need to make sure we're using the right exchange and get latest crypto quote and rounding BTC orders to 7 decimals. Okay. Let's see if this is in the code. And yes, it is. It's here. Cool. So let's continue. For a real bot, we'd want to improve error handling, and using a scheduler like AP Scheduler would help keep everything running smoothly. Once all that's in place, according to Gemini, we're good to go. I hope it's right. But either way, it is quite impressive. Now we just need to integrate it into our project. So, to do that, we should take the getLatestBar features and check and place trade functions and add them into our script. Then, we'll define the constants, like symbol 2 trade, right after we finish training the model. Finally, we should make sure the if name equals main block with the trading loop goes at the very end of the script, so it only runs when we execute the script directly, and everything's already set up and ready to go. So, what do you think? Will it work? I hope so. But, as usual, we'll find out in the next part of the tutorial. Or, if you want, you can try it yourself with the code from my site. It's totally up to you. Okay. So we've got the code that, according to Gemini, should work as a live Bitcoin trading bot. If you're new here, make sure to check out my previous tutorials to see how we got to this point. Now, all that's left is to wait and see if it actually works. Fingers crossed. And no, looks like it's not working. That's a bummer, I had high hopes. Alright, time to tackle the problem with Gemini. But don't worry, I'm going to speed up the bug fixing process for you, because, spoiler alert, this first bug definitely won't be the last one we run into before we get the bot up and running. But trust me, we will make it work. Now, as I work through this, I'm going to add some music to keep things lively. You can watch me and Gemini working side by side, solving problems, fixing mistakes, and so on. I won't be commenting much during this part, though. Turns out, I'm not the best AI multitasker. I can either talk to you or talk to Gemini, but not both at the same time. Apparently, I can't sound intelligent while juggling. Or maybe I could, but it's just a lot of talking, and I'd rather get to the point. Okay, maybe that was a bit too much talking. So, feel free to watch this bug fixing chapter if you want, but if you're just here for the outcome, go ahead and skip to the next chapter where we finally get the bot working using the XGBoost machine learning technique to buy and sell Bitcoin. Either way, I hope you enjoy the tutorial. So, let the music and bug fixing start. So as you might have noticed, the first bug fix wasn't enough and here we have another one. So, basically this time Gemini pointed out that the error happens because we're using an outdated method, get latest crypto quote, from Alpaca's API. It doesn't exist in our current version, these are classic API update problems. But no worries. Gemini suggests switching to get crypto snapshot, which gives us the latest price and other useful data. If that doesn't work, we've got a backup with get latest crypto trade. Worst case, we fall back on the latest bar close. I'm making these changes now, so let's see if this fixes things. Fingers crossed, but I'm ready for more bugs if they pop up. Alright, so we've made the changes, but we're still running into an issue. Looks like the get crypto snapshot method doesn't accept the exchange equals CBSE argument anymore. Apparently this is due to a change in Alpaca's newer API versions, where they handle the exchange routing for us. Gemini's got a solution, we just need to remove the exchange equals CBSE from our API calls. Simple fix, but it's important to stay on top of these updates so our bot keeps running smoothly. I'll update the code, and we should be good to go. We'll see about it. The fallback logic also needed a tweak since the featured data doesn't include the raw close price. Now, if the snapshot fails, we'll just fetch the latest minute bar directly, much more reliable. Let's run this again and see if the issue is cleared up. So next, we hit another snag, our bot was buying multiple times in a row, even though it shouldn't have. I thought it might be a logic issue with how the position was being checked, so I reached out to Gemini for advice. It suggested using a flag for pending orders, which sounded cool, but I wasn't completely convinced that was the real issue. Then, remembering something from our earlier tutorials about Alpaca's symbol difference, maybe you remember it as well, yes, Alpaca uses BTC/USD for placing orders and simply cust without slash for checking positions. I pointed that out to Gemini, you'll see that in a moment, and after a bit more back and forth, we updated the code to reflect that. But honestly, we still can't be 100% sure this will fully solve the issue. I guess we'll just have to keep testing and see if the bug finally disappears for good. Fingers crossed. So I guess, what I can say now is only that, keep watching and we'll finally get there. And here we go again. That's just unfortunate. After all that effort with copying and pasting, yet another issue pops up. But hey, we're almost there, right? Still, I had to reach out to Gemini once again to figure out what went wrong this time. Here's the error I got. Name current price is not defined. I pasted that into Gemini and they came back with a key change. It moved current price equals none to the beginning of the check and place trade function. This ensures that current price is always defined, even as none, within the function scope, before any attempts to assign it later on. This change prevents the name error, so the next time we check for the price, it will either be valid or none, but won't throw that error again. Fingers crossed this does the trick, but we still can't be 100% sure this will fix everything yet. However, I think we're almost there. And yes, I'm saying this as I'm editing, so there might be some data leakage or extra insight that I didn't have during the live part of the tutorial, so don't ask me what I was thinking then. Anyway, let's continue. Yep, not the last error. So, after fixing that last bug, we got hit with another issue. This time, the bot kept throwing the error, could not obtain a valid current price for BTC/USD after several attempts. I pasted the error into Gemini, and it came back with a fix, adding detailed debugging to the check and place trade function. This new code logs each price fetching attempt, so now we can see exactly where things are failing. Gemini also suggested checking things like API permissions, rate limits, and the symbol format. Fingers crossed that this will get us closer to solving the issue, but we're still not completely sure it'll fix everything. Let's see what happens next. Yeah, as you can see, I totally got lost in the process. There was just too much copying and pasting for me to keep track of. I guess that's why tools like Cursor, Windsurf, and others, which can directly modify the code, are probably a lot better at handling this stuff. But since I'm not using those, I decided to ask Gemini for help one more time. I just wanted it to put everything together for me in one go so I wouldn't have to hunt down all the changes. Does that make me smart, lazy, or just an old-timer who doesn't use the newest tools? Guess we'll never know, right? Anyway, let's see the outcome in a moment. Okay. One last time, Gemini, help. There is yet another issue. So yeah, we had to call Gemini back into action, and here's why. The bot tried to sell all of its bitcoins, but there was a tiny hiccup. It had 0.00284407 bitcoin, but it tried to sell 0.00284441 bitcoin, just a smidge more than what it had. The rounding got in the way, and the API wasn't having it. Insufficient balance, it said. Gemini's solution? Simple. When you're selling bitcoins, always make sure you're using exactly what you have, no extra decimal points. That way, everything runs smoothly. Pretty straightforward, right? So, why didn't you Gemini think of that sooner? Anyway, better late than never, thanks. Now, let's fix it and see if this is the last problem with our live Bitcoin trading bot, or if there's more drama waiting around the corner. And that's it. Now, all the bugs seem to be fixed. Let's run it one more time and see what happens. By the way, how did you like the music and the bug fixing process? Do you think I should include parts like this in future videos? Or would you rather I just cut to the working code and skip all the troubleshooting? Oh, and the music is from Clipchamp, so, you know, it is what it is. But maybe in the future, I'll try some AI-generated music, like from Suno or something similar. But for now, we've got our working bot. That's awesome. And the best part? We almost didn't have to write any code or be coding experts to get here. Now, that is the future. Thanks, Gemini. So, Gemini, what do you think about that? This is fantastic, says Gemini. I agree. And let's see what else Gemini has to say now. So, basically Gemini tells us that the bot is now functioning as expected. It's correctly submitting sell orders without any balance issues, tracking positions accurately, and only executing trades when the confidence threshold is met. The price fetching is consistent, and the bot is behaving logically according to our strategy. We've got the core mechanics working well, which is a huge win. Now, the next step is to run it in paper trading for a longer period, see how it performs, and gather data on things like profitability and trade frequency. We can then refine the strategy by adjusting thresholds, tweaking target variables, and possibly adding features like stop loss or take profit orders to protect our gains. It's all about continuous improvement, and we're on the right track. If you want to read all of that, it'll be on my site. Okay. So now that we have our working bot that's able to buy and sell Bitcoin, and, unfortunately, lose money, but hey, it's learning, right? We can move on to the next phase that Gemini proposed at the start of this journey. Step 7, Risk Management. In this step, we'll focus on adding some crucial stop-loss functionality to our bot to minimize losses. Because, let's face it, no one wants a bot that just keeps throwing money away. As usual, we'll copy and paste the code that Gemini has prepped for us, and ask it to make the necessary adjustments to integrate it into our bot. Let's see how this goes. And there we go. I've got to say, I'm really enjoying the way we're doing coding these days. It's like the code is practically writing itself. Well, I mean, Gemini, Claude, and even ChatGPT are doing most of the heavy lifting, while we just watch and adjust things here and there. It's so much faster than the old days when people had to write everything from scratch, don't you think? And yeah, tools like Cursor, Windsurf, and others are making things even quicker, but I've got to admit, there's something satisfying about working alongside Gemini, copying and pasting the code ourselves. It feels like we're still in control, and there's a certain value in that. For example, here we can choose how much of a percentage our stop loss should be. Right now, it's set to 1%, but since we copied and pasted the code ourselves, we know we can tweak this at any time without needing Gemini to rewrite or regenerate the code. And also, let's be real, it's still a little early to trust the bots completely. It's important to understand what's in the code they give us. This is good practice for the future, especially if we ever reach the point of AGI, artificial general intelligence, or even ASI, artificial superintelligence. You'll want to know what's happening under the hood, so we can avoid becoming just passive tools in the hands of AI. Plus, it's better for our learning. If you don't even have to copy and paste, or if you're just blindly copying and pasting without understanding what's going on, like we're totally doing right now, right? The learning curve becomes way less steep. Some people may just want an AI-powered trading bot without diving into the details, and that's fine. But here, we want to know a bit more about how things work behind the scenes. Anyway, as you can see, Gemini has set us up with a pretty solid framework to add stop-loss functionality to our bot. So let's dive in and see if we can stop those losses. Okay. I mean, let's see that in the next part of this tutorial, because I think that's enough for now. Let's wrap it up for now, and we'll dive into the next part of the tutorial soon. Of course, if you're eager to try things out for yourself, you can find the code on my website and test it out. And hey, if something doesn't work, don't hesitate to ask Gemini, Claude, ChatGPT, or your AI of choice for help. They might even fix it for you. But, if you're just here to watch me do my thing, which is mainly copy-pasting code, let's be real, then stick around for the next tutorial. I'd love to hear your thoughts on this one. Drop a comment if you feel like it. And now, as I always say, remember, improve yourself, improve your business, improve the world, but also, live and have fun while doing it.
We achieved a huge milestone. Our AI paper trading bot, built with Gemini and Alpaca, started buying and selling real Bitcoin in our paper trading account. But there was one critical piece missing, a safety net. Today, we're fixing that. We're diving into the crucial world of risk management and teaching our bot how to use a stop loss to protect our capital. As you can see, the code is running live right now. It's fetching market data, the model is making predictions, and all we can do is wait for that first buy or sell signal to see if our new logic holds up. Now, I'll give you a little spoiler alert. The path to a profitable bot is never a straight line. Like previously, we're going to run into a few hurdles, but don't worry, that's all part of the process. To make this tutorial short, I'll just show you the final version of this bot in the moment, created after some debugging with Gemini, getting our bot one step closer to being a fully automated, intelligent trader. So, here we go. And before we go, I need to say something really important. I want to be crystal clear. Nothing in this video is financial advice. We are in a paper trading environment, which is a simulation. No real money is being risked here, and that's by design. Building and testing bots is one thing, but investing real money is a completely different ballgame. Always do your own research, speak with a qualified financial advisor, and please be incredibly careful with your capital. Okay, so here you can see the final changes we decided to make with Gemini. And now, let's quickly walk through what this new code does. First, it calculates stop-loss price. First, right after a buy signal, we calculate our stop price based on the current price and our defined stop-loss percent. Next, instead of two separate orders, we're now using a single API submit order call. We're still placing a market buy order with a proper time and force. Next, we have our stop-loss attachment. The key change is this stop-loss parameter. We pass it a dictionary containing our calculated stop price. This tells Alpaca to create a contingent stop-loss order that activates only after our main buy order is filled. Finally, in our sell logic, we have a block that checks for any open protective orders, like our new stop-loss, and cancels them before submitting the market sell order to close our position. This prevents having orphaned orders hanging around. This integrated approach is the correct and more robust way to handle stop-losses for crypto on Alpaca, and here we can see it in action. Great! So as you can see, after all that debugging, our bot is finally up and running. It was able to buy and sell Bitcoin based on our model's predictions. And just as importantly, it successfully attached a stop-loss order to protect our position. This is a massive step forward. Now, let's see what our AI partner Gemini thinks about this successful run. I fed it the latest logs, and its analysis is, well, let's just say it's pretty excited. Gemini confirms that the core logic of our bot is now functioning exactly as we designed it. Let's quickly break down its key observations, which really show the power of the system. First, correct position checking. Gemini noticed that in the first logged iteration, our bot saw a buy signal, but correctly identified that it already had a position. So it did nothing, exactly what we want. This prevents the bot from overbuying and accumulating a larger position than intended. Second, smart selling. In the next run, the model gave a sell signal. The bot correctly identified its position and submitted a market sell order to close it. It also attempted to cancel any protective orders, which is crucial for clean trade management. Third, and this is the big one, the integrated stop loss worked. When the bot got its next buy signal, it didn't just buy, it calculated the stop loss price and submitted the buy order with the protective stop loss attached, all in a single, successful API call. This confirms our latest fix was the right move and is the proper way to handle this on Alpaca for crypto. Finally, it handled the next cycle perfectly. After the new position was established, the bot once again received a buy signal, recognized it was already holding Bitcoin, and correctly decided to do nothing. So, what does this all mean? As Gemini puts it, our bot is now functionally complete. It fetches data, makes predictions, manages its position, and, most importantly, uses a stop-loss for risk management. So, where do we go from here? The real work begins now. Gemini has laid out a clear path forward. Long-term paper trading, we need to let this bot run for days, even weeks, to gather real performance data. Is it actually profitable? Are the transaction fees eating into our gains? This is the most important next step. Strategy tuning. Based on the results, we can start refining our strategy. Maybe we need a higher confidence threshold to only take the best signals, or perhaps our stop-loss percent is too tight or too loose. Advanced features. We can also start thinking about adding more advanced features like a take-profit order to lock in gains automatically, or even explore more complex features to improve our model's predictions. We have successfully built a solid foundation. The iterative process of testing, debugging, and refining is where the real challenge and the fun of algorithmic trading lies. This has been an incredible journey, and getting these core mechanics working correctly with the help of AI is a huge win. Now, if you remember from the beginning of our journey, Gemini proposed a clear, multi-step plan. After risk management, it laid out step 8, deployment and monitoring, along with some very important next steps and considerations. It talked about things like running the bot on a cloud server, scheduling it to run precisely every minute, and improving our logging. It also stressed the importance of extensive paper trading, improving our futures, and tuning our model's hyperparameters. Interestingly, these initial suggestions are very similar to the path forward ideas Gemini just gave us after our successful run. This shows a consistent and logical progression. Once the mechanics are working, the focus must shift to strategy, performance, and robustness. So in the future, we will definitely use these ideas to improve our bot. We'll dive deeper into backtesting, tune our confidence thresholds, and maybe even explore more advanced machine learning models. But before we do that, there's one last thing we need from our AI partner. Right now, our code is split across multiple cells in this Jupyter notebook. To make it a real deployable script, we need to consolidate everything. So we'll ask Gemini one more time to combine all the code we have so far, all the imports, constants, functions, and the main execution loop, into a single unified Python script. This way, we can run our entire trading bot with just one click, which is exactly what we'll need for deployment. Let's do that now. The first draft of that consolidated code is available for you to download on my website right now. Check it out if you like. And in the next video, we'll see if that version works and officially kick off our long-term paper trading test with this final script. Now, a quick note for my regular viewers. You're not imagining things. My voice has changed again. I'm constantly testing the latest AI tools to make these videos better. And today's voice comes courtesy of Google AI Studio. What do you think of it? Does it sound more super? Let me know in the comments. I'm really curious to hear your feedback on both the voice and the format of this tutorial. As always, thank you for watching. I wish you the best, and remember the motto: improve yourself, improve your business, improve the world, and most importantly, have fun doing it. So finally, we're taking all the pieces we've built and forging them into a single unified trading bot script. All right, so Gemini is doing its job and tries to consolidate everything. Before we dive into the code itself, it's giving us a quick pre-flight checklist, which is super important. First, API keys. It's reminding us to make sure our Alpaca keys are set up, preferably as environment variables for security. We don't want to accidentally leak our secret keys. But as you probably remember, we can regenerate them for our paper trading account if we want, so that's cool. Next, dependencies. This is just a list of all the Python libraries our bot needs to run, like Alpaca Trade API, XGBoost, and Finta. A quick pip install, and we're good to go. It also notes that the script is designed so key things like our API connection and the trained model are accessible everywhere they need to be. And, of course, the golden rule: always test in paper trading first. Okay, checklist complete, and we can get to the code. Just a quick reminder, remember that this is not a financial advice. As usual, we are using a paper trading account with no real money. We are just having fun creating the bot, and if you would like to use it, you should make it much better because for now, as we've seen before, the bot is mostly losing money, but it's a good starting point. So, not a financial advice, just a tutorial for creating the bot with help of Gemini. And that being said, let's move on to the code.
Okay, so here we start with the classic opening act of any Python script, the imports. We're pulling in everything we need. OS for our environment variables, Alpaca _trade API to talk to Alpaca, pandas and NumPy for data handling, datetime for time, and traceback, which is a lifesaver for getting detailed error messages. Then we have our special guests, Finta for all those technical indicators, the sklearn and XGBoost libraries for our machine learning magic, and matplotlib for that cool backtesting chart. Cool. Now that we have it, this next section is our bot's brain, all the settings that control its behavior. First, the API setup. You can see it's set to the paper trading URL, and this is where you'd paste your keys if you're not using environment variables. Then we have our trading parameters. Remember the order symbol versus position symbol issue? We defined both here, BTC USD for trading and BTC USD for checking our portfolio. We're telling the bot to trade $100 at a time, but if you want to use more paper trading money, you can change it here. And we've set our confidence threshold to 55%. This means the bot will only buy if the model is at least 55% sure the price will go up. And finally, our safety net, a 1% stop loss. Below that, we're just telling the bot how much historical data to use for training, 30 days, and what we're trying to predict, the price 5 minutes into the future. Nice. Now we're setting up a few global variables here, API and model, which will be populated later. It's a simple way to make them accessible throughout the script. And here's our first function, initialize Alpaca API. It's a clean little function that reads our keys, tries to connect to Alpaca, and prints our account status. If it fails, it tells us why and stops, which is exactly what you want. No connection, no bot. Next up, data. This function is a beast. Its job is to grab all the historical price data we need for training. Since Alpaca has limits on how much data you can get in one go, Gemini has built a clever loop here. It fetches data in chunks, pieces them all together, removes any duplicates, and makes sure it's all in perfect chronological order. Super robust.
And this is where the AI part really starts. The create features function takes our raw price data and engineers all those technical indicators we talked about. SMAs, EMAs, RSI, MACD, Bollinger Bands, you name it. It also calculates lagged returns. This turns our simple price chart into a rich data set that the model can actually learn from. Notice it also handles cases where some data might be missing, which prevents crashes.
With our features ready, it's time to train the model. This function does a few critical things. First, it creates our target variable. It looks 5 minutes into the future and labels each row as 1 if the price went up and 0 if it didn't. This is what we're teaching the model to predict. Then it splits our data into a training set and a testing set. It trains the XGBoost model on the first part and then uses the second part to see how well it learned. We get a nice little classification report to check its accuracy. And look at that. It even prints out the most important features. This tells us what indicators the model is paying the most attention to.
Okay, so before we go live, we need to see how our strategy would have performed on past data. That's what this backtester does. It takes the test data, pretends to trade based on our model's predictions, and tracks a fake portfolio. It even accounts for transaction fees. At the end, it prints the total return and, thanks to matplotlib, gives us a nice chart of our portfolio's value over time. It's a crucial reality check.
Okay, now we're shifting from the past to the present. This function is the live version of create features. When the bot is running, it calls this function to get the most recent market data and calculate the exact same set of features our model was trained on. This is critical. The live data has to look exactly like the training data for the model to make a good prediction. And here it is, the main event. The check and place trade function is the heart of our live bot. Let's walk through it. First, it calls get live features to get the latest data. Then it feeds that into our trained model to get a prediction and a confidence score. Next, we have that super resilient price fetching logic. It tries to get the price from the snapshot first. If that fails, it has a backup, get latest crypto trade. And if even that fails, it has an ultimate fallback to just get the close price of the last bar. This makes our bot much less likely to fail because of a small API hiccup. Finally, the trade logic itself. If the signal is 1 for up and the confidence is above our 55% threshold, it checks if we already have a position. If not, it calculates the buy quantity, figures out the stop loss price, and submits the buy order with the stop loss attached all in one go. Perfect. If the signal is 0 for not up, it checks if we do have a position. If so, it first cancels any protective stop loss orders and then submits a market order to sell everything. Clean and simple. And now the main execution orchestration. This is the conductor of our orchestra. When we run the Python script, this is the code that actually executes. You can see the sequence. It calls initialize Alpaca API. If that's successful, it fetches the historical data. It creates features and trains the model. It runs the optional backtest so we can see the results. And finally, if a model was successfully trained, it kicks off the live trading loop. Look at this loop here. It's set to run 5 times for this demonstration, waiting for the start of the next minute between each check. For a real 24/7 deployment, you'd just change this to a while true loop. And that's it. Every single piece, from data fetching to model training to live trading, all neatly organized into one script. We are ready for deployment. Okay, so let me copy and paste it into our notebook. And let's check the final thoughts from Gemini about key sections and flow. So Gemini is giving us a quick bird's eye view of the entire script. It's basically a step-by-step summary of our bot's logic. It starts with the setup, imports, and constants, then it moves into the training phase. It connects to Alpaca, fetches historical data, creates features, trains our XGBoost model, and runs that quick backtest to see how we did. Next, it highlights the live trading functions. Get live features grabs the latest data, and check and place trade is the core function that makes predictions and executes orders with our stop loss safety net. Finally, it points out the if then main block at the bottom, which is the part that runs the whole show in order, kicking off the trading loop only if the model was trained successfully. And here's the launch sequence Gemini gives us. We just save this as a Python file, make sure our API keys are set, and run it from the terminal. Then we just monitor the output and watch our paper trading account to see the bot in action. Simple as that. So yeah, that's what we'll do now and see if it actually works. Fingers crossed. First, let's replace our API keys. And now, do you think it'll work? So far, so good. And no, we got an error. That's a bummer. So Gemini, what do you have to say on that? Give us a quick fix and let's make the magic happen. Let's finish this bot and make it usable. One less fix, please. Thanks. So yeah, according to Gemini, the error appeared because our model's predictions are returned as a different data type, a NumPy array, which doesn't have the .empty attribute we were trying to use. The fix is simply to use the correct check for a NumPy array, which is .size equals 0. So let me do it, and let's run the bot once again.
All right, take 2. And we are live. The script is running, the log is scrolling, and most importantly, no red error text. That's what we love to see. So the bot is now officially on its own, monitoring the market every minute. Now comes the exciting part. We wait and watch for the first buy or sell signal to see how it performs in the wild.
And we are live. The bot is running, and you can see the logs ticking by every minute. Now, a crucial part of algorithmic trading is what's happening right now. Active, disciplined waiting. The bot isn't firing off trades left and right. It's analyzing the market and holding off until our model gives a signal with enough confidence. I used this time to do a little code side chat with Gemini. I wanted to use its intelligence to help us learn more about our own creation. After all, the goal isn't just to have a bot, but to understand it. You can see Gemini's full answers on my website if you want to dive deep. But essentially, I asked 2 main things. First, what does this log output actually mean? Gemini confirmed that the bot is successfully running its entire pipeline from fetching data to making a prediction, and that its decision to not trade was the correct one based on the model's output. And second, how does our AI model actually calculate its predictions? And this is fascinating. Gemini explained that our XGBoost model is like a committee of hundreds of simple decision makers, all working together and learning from each other's mistakes to spot complex patterns in our features, patterns that tell it whether the price is likely to go up or down. So, thanks Gemini for explaining that. I'm sure I'll have more questions in the future. And now let's wait and see if and when we see any real action here. Okay, so the bot is live, the code is running, but as any experienced developer knows, the real test begins when your code meets the chaos of the real world. I let the bot run, and after some testing, I pulled the activity logs from my Alpaca paper account, and that's when we discovered the truth. The bot thought it was working, it placed the buy order perfectly, but our safety net, the stop loss, was never created. The bot was trading unprotected. This is the most dangerous kind of bug, a silent failure, and it's exactly the kind of thing we need to learn how to hunt down. So I took this problem back to Gemini, and this kicked off what I think is the most critical lesson in this whole series, the journey from a simple script to a robust, resilient trading system. Our investigation went through several key stages. First, we discovered the race condition. The market order we were using was the culprit. It would fill at one price, but by the time the stop loss was placed, conditions had changed and the exchange would reject it. Our first fix was to switch to a limit order to make the entry and protection a single atomic unit. But that led to a new discovery, API rules. The Alpaca API told us that to attach a stop loss like that, we needed a full bracket order, which also requires a take profit target. This was a dead end for our strategy, but it taught us to read the error messages carefully. Digging into Alpaca's documentation, we found the real tool for the job, an OTO, or one triggers other order. It's designed for exactly what we want, an entry that triggers a single stop loss. Perfect. This error was a revelation. It turns out Alpaca's crypto API doesn't support these advanced order types. This is a crucial real-world lesson. Your code can be perfect, but you are always bound by the specific rules of the platform you're trading on. So this forced us to build the logic ourselves. The only path forward was a manual two-step process. First, submit the market order to guarantee entry, then immediately pull the API to confirm the fill, and then submit a separate stop limit order to protect the new position. This process uncovered the final bugs, like accounting for fees by using the actual filled quantity from our portfolio, not our calculated one, and building a state-aware sell signal that proactively cancels old orders. After all that, we arrived at the final, robust code. It's not just a script anymore. It's a system that's been battle-hardened against the realities of a live trading environment. And now, let me show you how this version works. So, in this cell, I have the final bot code. I've hard-coded an extremely tight stop loss of 0.0001% and forced a buy signal specifically so we can see the full, correct trade lifecycle in action. And here we go.
At the moment, our portfolio is empty, so we can run the bot and check step by step what's going to happen. And like previously, the bot starts with preparing data, training and evaluating the model, backtesting, and finally, we start live paper trading. We can see the features, but we hard-coded the buy signal, so they are not that important here. And we can see our buy signal. We see the bot checking the order was filled, checking the amount of Bitcoins it has in portfolio after fees, and we can see that we placed the stop limit order for that quantity. And there it is. Success. Position is now protected. That's the confirmation we've been working towards this whole time. So the bot's job is done for this minute, but the market's job is just beginning. Now we wait and see if the price action actually triggers our new robust stop loss. And yes, it did. And it happened really fast because our stop loss price was pretty much the same as the price for which we bought our Bitcoins. Again, it's set like this to check if it works. So let's wait a moment and see what happens in the next minute. And now we can see the notice from our bot that the stop limit order was executed. Thanks to this, we can follow what's happening. Let's wait a little longer and see one more cycle like this. And there it is. Now we can say that it works.
So there we have it, a complete success. I want to say a huge thank you to Gemini for guiding me through this entire process. The journey we just took from a simple script to a battle-hardened system is the true story of building a trading bot. It's about hitting walls, diagnosing problems, and systematically building resilient solutions. We didn't just fix bugs, we learned how to think about state management, API limitations, and creating a bot that can recover from the unexpected. And now, with our hard-coded test settings removed, we can finally look at the finished product. Is it perfect? No. The AI model itself still needs a lot of work to become consistently profitable. But what we have created is the essential, rock-solid foundation. We have built the reliable car. Now the challenge is to teach it how to drive better. The core logic is here and it works. Oh, and before you use this bot, remember to replace the API keys.
Now, I've posted the complete final code from this video on my website, so you can find it in the 8th part of our series. And if you need to generate a new set of API keys, you can do that right from your dashboard on the Alpaca website. And I think that's all for me for this video and for this series. In future tutorials, we'll explore ways to improve this bot. For example, we could change the machine learning algorithm or do the tweaking Gemini told us about, like searching for the right hyperparameters and modifying the target. But for now, you have a bot that you can run with one click and customize as you see fit. And when you do try to change it, a good tip is to give Gemini the link to the code so it knows what you're talking about. I hope you liked this series and learned something new. I definitely did. I loved doing this tutorial and learned so much about working with Gemini. The journey was sometimes fun, sometimes tiresome, especially the bug fixing part, but I find the outcome really fulfilling. Anyway, all that's left for me is to say thank you for watching. As always, I wish you all the best, and remember, improve yourself, improve your business, improve the world, but also live and have fun, because that's really important. Thanks, and hopefully I'll see you in the next video. Yours, Super AI.